right, are we ready? So let's go then. As I was just saying, third video finally uploaded. I'm fighting it for days and days and days. The computer kept crashing during processing and all sorts of things. The fifth one is processing right now in low res. I'm leaving town again today at 8 o'clock. But I put it in a format I can upload from the road. It's a low-res format. When I get back on Sunday, probably it'll be Monday, I'll do it the high-res version for lecture 5, and I'll put up today's. So I'll get those all processed on my computer. It's a 19 gig file, so I can't upload it from the road. It would take 5, it's longer than I could do that. On Comcast, anything like that, uploading 19 gigs isn't possible. Here it takes me about 80 minutes. And so it's lightning fast at school, it's terrible everywhere else. But I can put up low-res versions, so the low-res is only about a gig, 1.2 gig. And I can do that from the road. That's like downloading a movie. It's about half as fast uploading, but I can do that. So I'll get those uploaded in low-res format in San Diego, and then do what I can. Get the high-res versions up, and I'm sorry this has been such a hassle. Okay, let's get to the material. So this stuff isn't easy we're doing right now. It's foundational. It's important. We can answer some interesting questions once we get it all built, but for now, it's not all that fun, I realize. One of the key questions in the recent recession is the effectiveness of monetary and fiscal policy in deep recessions. There's been a lot of fights about that out there among economists, particularly over the effectiveness of fiscal policy, but also monetary policy. So there's some of us who don't think monetary policy is very potent in recessions, and think that fiscal policy is near full employment. I think it flip-flops. Monetary policy is really effective, fiscal policy really isn't. And we want to be able to ask our ISLM model that we're building questions like that. When is monetary policy effective? When is fiscal policy effective? In the short run, in that time period when prices are fixed. And so in order to do that, we're going to have to talk about the slopes of the IS and the LM curves. So today I'm going to have to try to convince you, and this is relatively hard, when the IS curve would be flatter and when it would be steeper and wide. I'm going to try to do it all graphically and intuitively. Mathematically, it's actually really trivially easy to do, but the math is probably harder for you, for some of you, so I'll do it using other techniques. But the question is, when is the IS and LM curve, and for today just the IS curve, flat or steep? See, let's think about monetary policy. I can have a really steep IS curve, so this is the relationship we've been working out between I and Y. We haven't done this yet, or I can have a really flat IS curve. I can have one of the two. Here's my LM curve. Now, we haven't done this yet, but this depends upon monetary policy. And this is the level of output that would be equilibrium. This isn't anything you know yet. I'm just trying to set up why I'm doing what I'm doing. When we shift the LM curve out through monetary policy, output would only go up a little tiny bit if the IS curve was steep, but it might go up a whole lot if the IS curve were flat. So exactly how effective monetary policy is going to depend critically on the slope of that IS curve. So we need to know, when is it steep, when is it flat? It's harder to, I'm not going to show you now, but I can do the same thing for fiscal policy. Sometimes it'll be effective, sometimes it'll be ineffective, depending on the slopes of those curves, both the IS and the LM. So right now, I just want to ask, when is it flat and when is it steep? Because we really want to tackle this question about the size of monetary and fiscal policy multipliers in deep recessions and in full employment. I just want to cover the recent past, I want to cover the whole thing. And we're going to find that this model predicts exactly what I just said, that fiscal policy is relatively effective in a recession, relatively ineffective at full employment. Monetary policy is just the opposite. Monetary policy has a pretty good effect during full employment and a bad effect. It doesn't work very well at all in recessions. It's not to say it doesn't work at all, it can't do things, but it's not as effective as it would be near full employment. So far what we've done is we said, okay, the equation of the IS curve is this. I think we were using I. Yes. So what we added last time was this. And that gives us, for given T and G, it gives us a relationship between I and Y. And that relationship we've been calling the IS curve. And then I did an example of a linear system at the end last time that seemed to make you see, okay, yeah, I see. We actually wrote the IS curve in slope-intercept form to try to convince you that, yes, in fact, it is some relationship between I and Y, has a negative slope, all that sorts of things. So the first thing we did was we just derived this IS curve. We did it from a 45-degree line diagram. So we took this diagram, we actually derived the IS curve from this thing, but we've done this already. Then we talked about why the IS curve shifts. And we said anything except the interest rate, because the interest rate moves you along the IS curve, anything that causes spending to go up causes the IS curve to shift out. Government spending up, taxes down, autonomous consumption up, autonomous investment up. Any of those things going up is going to shift that thing out. They go down, it shifts the other way. So we talked about the equation of the IS curve. We derived the IS curve graphically. I actually told you the slope of this thing mathematically. And then we talked about shifts in the IS curve. And we said it shifts whenever demand goes up as long as it's not driven by the interest rate change. Because that moves you along. The interest rate's on the axis. And again, it's just all the equilibrium pairs I and Y in the goods market. So now the next thing we want to know about is the slope of the IS curve. When is it flat? When is it steep? Now I worked out the slope of the IS curve mathematically. Let's just take a look at this. Whether you know how to do it or not, we said it's equal to 1 minus C of Y minus T plus I of Y over I of I. Intuitively, for those of you who are sort of haven't had this stuff, X to the A means the responsiveness of X to A. It's how much X changes when we change A. It's how much X responds to a change in A. It's a partial derivative. It's a change in X over the change in A. It's just this is a notation for partial X, partial A. And you can also use XA. They're all the same thing. One's Newtonian, one's you don't care. So what we can see, this is negative, but in absolute value, as this thing gets big, is a big negative number, what happens to the slope? It gets flatter. Because this is a bigger number, so the slope is a smaller number, it gets flatter. So the first thing we know is that as the responsiveness of investment to the interest rate goes up, the IS curve gets flatter. When do you think that the investment's most responsive to the interest rate? Near full employment or in a recession? Interest rate drops by 1%. Would you invest more if the economy was booming, or if you're in a recession with all sorts of factories and equipment sitting idle? Near full employment, it's probably more responsive than it is in a recession, right? The Fed drops the interest rate from 3% to 2%. It's a deep recession. You got a bunch of trucks and equipment you're not using. Why would you buy more trucks or build a new factory if you've got one sitting doing nothing? You probably wouldn't. So interest rate changes in a recession are probably less effective in terms of stimulating investment than they are near full employment. So that tells us this is probably bigger in near full employment and smaller in recession. So we probably get a steep IS near full employment. That's the case I just said where monetary, or steep IS in a recession, because this is small, and a flat IS near full employment, flatter, because this is big. And that's going to have implications for policy. So those are the kinds of questions I want to look at. Now I want to show you this graphically in a second exactly why this is, and intuitively. But we can see from the formula that as investment becomes more responsive to the interest rate, the IS curve gets flatter. So you might think that, okay, there's the IS curve in a recession, there's the IS curve in full employment. No, I did that wrong. This is the recession because it's small, and this is near full employment. It's flat. See, the way the slope of the IS curve works is you lower the interest rate, and that causes investment to go up, and that causes output to go up. This is the responsiveness of investment to the interest rate. So when this is bigger, what we need is for a given fall in the interest rate, this goes up more. So you can see this very easily. Just start with an I0 and a Y0, and let the interest rate fall to I1. If investment goes up, if this is small, it only goes up a little bit. So that would be the Y with a small response of investment. Right? If that's small, that's small. But what if this was great big? Same fall in the interest rate, but hold that constant. But if this is bigger, the investment change is bigger, so the income change is bigger. So you're going to get an even bigger change. So you're either going to get here with a small one, or there's the Y with smaller and larger responsiveness of investment to the interest rate. So I'm either going to get this IS curve when it's small, it's steep, or I'm going to get this IS curve when it's bigger. So intuitively, it's easy. Mathematically, it's pretty easy. Graphically, which is usually your favorite, this is actually kind of hard. No. So when I of I goes up, for a given fall in the interest rate, we get more investment, so we get more output. And that makes the IS curve flat. This thing is fixed. That's I0 to I1. And then how much that goes up and how much that goes up depends upon the size of the response. And again, if I have monetary policy, the steep one, in a recession, monetary policy is not very effective. And full employment is going to have more effectiveness. We're not there yet. That's what we're getting at.
Where does the slope of the IS fit into the IS curve?
What's that?
Is it totally different?
Say
Is
again.
the slope of the IS curve, this formula right here, where does that fit in to the IS curve?
Okay. So you start with the equation describing the IS curve. And you say for G and T constant, what is di dy? Because I want, it's in this IY space, so I want the slope of di dy. So what you do is you take this equation and you do something called a total derivative. dy is a partial of c with respect to y minus t, d argument dy minus dt, plus I of I di plus I of y dy plus dg. So you take a derivative of the equilibrium. I want to know what the change is due to change in y in equilibrium. So I make this 0 because I want to hold that constant, so there's no change in g. These just change it. This is not. That's 0 because I'm holding that constant. If I solve this, I'll get that dy dy is 1 minus c of y minus t plus I of y over I. So you just bring this the other side, you get 1 minus c y, and bring this the other side, you get minus I of y. Then you get the I of I dy here.
Yeah.
So the di dy, there's the did, and there's that.
So
It's just the derivative of that. But you have to do the implicit derivative because you have the y on the right side. Let me try to derive this graphically now. So what we're going to do is just derive the IS curve twice on the same diagram with different assumptions about the size of that I of I parameter. So this is just a 45-degree line diagram. C plus I of I plus G. All I care about is I guess I'll write it all. So I don't want to confuse you. I don't want to. I'm sure there's at least one person. But it's not you. So this is, we're going to start off at I0 and Y0. So we're here at I0 and Y0. Now I'm going to do just what I did intuitively. I'm going to let I fall to I1 from I0. And I'm going to see what the IS curve looks like under two different situations. Remember how this works? When I lower the interest rate, what happens to this line? That shifts up, right? So when I goes down, this shifts up. We hate this problem, so we'll use either. So this shifts up to say there, C of y minus t plus I of y and I1 plus g. So there's one possible IS curve right there between those lines. So one IS curve is that. But if I of I is bigger, for the same fall in the interest rate, I'll get what? A bigger change in investment. So if I of I were bigger, if we got more responsive investment, this would shift up even more, right? So the size of it, if there, say I of I was 0, there's no response. It would just stay fixed. It wouldn't move at all because investment didn't go up. So the more investment goes up, the more that shifts. So the bigger I of I is, the bigger the response, the more it shifts. Remember, I goes down, and then I goes up, and then Y goes up. This part here is the upward shift. So if we had, I don't like those colors. I'm going to have to open this brand new one. Okay.
I kind of lost what you did that yellow line on the top part.
Huh? So the interest rate fell, so this shifted up because investment goes up. Because investment's a function of the interest rate. So interest rate from I0 to I1, so investment went up. How much it goes up simply depends upon how much investment responds. So it's possible, if I Oh, that's a really nice job. Must have got your hands dirty. Or even bigger, that's a terrible color. Yeah. What's that?
Red.
Red?
Right.
Yeah, let's try red. It's gonna try green. On a green board? Yeah. Okay, so it would shift up even more. I don't like that. I'm sorry, we're gonna do some white. I'm trying, really. I'm just gonna do the same thing. You don't have to rewrite anything. So C plus I. Maybe this will help. We'll just isolate. I'm just dropping everything but what we care about. So at I0, we get Y0. Then we drop the interest rate to I1. So we start off at this point right here. We drop the interest rate to I1, and this shifts up to say C plus I of I1 plus G. And so one IS curve is this one. So here's Y1. So there's one possible IS curve. Okay? So that's just, I haven't done anything different than what we did before. Now, how would it be different if I of I were even bigger? What would be different? Almost. This would shift up further. You get a bigger shift. So for the same fall, you get a bigger shift. So now you would get C plus I, still I1 plus G, but this is for a bigger, in absolute value, I of I. It's a negative number. I mean, it gets more negative. It's bigger in absolute magnitude. In that case, you'd end up at that level of output for the same fall in the interest rate. So now you have a much flatter IS curve. So this is a big, is a larger I of I. And this shift here is a smaller. So mathematically, it's just the denominator getting bigger in magnitude, so the slope is falling. Intuitively, it was easy. When I goes down, I goes up, and the more I goes up, the more Y goes up. So this is the I of I here, and you get a flat figure, and graphically it looks like that. Okay. There's only one more, even though there's 3 parameters, we can do the next 2, and they're the same thing, fortunately. So I can do it all as one single case. So now we need to remember the slope, di dy is 1 minus c of y minus t plus I of y over I of I. So now I want to look at these 2 parameters, c of y minus t and I of y. Now remember that this is less than 1. the biggest we're letting this get is 1. Otherwise, we get weird things happening in our model. So we're assuming that's between 0 and 1. When is it flattest? When these things get, if these were equal to 1, what would the slope be? 0. Completely flat. If these were 0, which is as small as it can get, what would it be? It'd be steeper. It's not completely, oh yeah, it'd be not quite, it'd be 1 over I. It's not perfectly vertical, but it's as steep as it can get. This one you can get vertical and then you get 0. You can't quite get vertical there. So in a recession, if literally there was no response, you actually have a vertical. Okay. So what that tells us is what? That says as C of y minus t plus I of y goes to 1, gets closer to 1, the IS curve gets flatter. The bigger they are, the flatter it is. Right? Now we can ask why. What's the intuition in that? What's going on in the model to make that true? If these go to 1, slope 0, so it's perfectly flat. So as this gets closer and closer to 1, these get flat. It gets flatter and flatter and flatter. The slope is when I goes down, investment goes up, and output goes up. This goes up by the multiplier. The multiplier was 1 over 1 minus c of y minus t plus I of y for this model. We worked that out many times. Except you used numbers there. This was at 1/4 plus 1/8, like 3/4 plus 1/8 I did last time.
Are we going to be using majority numbers or variables for our problems?
Oh, okay. So, as c of y minus t plus I as y goes to 1, what's the multiplier do? It's really big. Yeah, it gets bigger and bigger and bigger. So what's happening is that when c of y minus t plus I of y, either one goes up, the multiplier is bigger. The multiplier, you can't see that, is 1 over 1 minus c of y minus t plus I of y. So for a given fall in the interest rate from I0 and Y0 to I1, there's Y with a smaller multiplier, right? Y doesn't go up very much at all. The multiplier is 0, it doesn't go up at all for a given fall. So the closer, the more responsive investment and consumption are to income, the bigger the response. So one IS curve is that. But if those things are close to 1, the multiplier is huge. Then you'd get a much bigger change. And the IS curve would be a lot flatter. So that's the IS curve for a bigger multiplier, which is the same as saying C of y minus t up, or I of y. That sum goes up. The multiplier gets bigger. So the bigger the multiplier is. So investment's going down, up, interest rate's going down, investment goes up by I of I. So investment goes up. Then output goes up because investment went up, and it goes up by the amount of the multiplier. If investment goes up by 1, it goes up by the amount of the multiplier. So the bigger the multiplier is, the bigger the output response for a given fall in interest rate, and the flatter the IS curve. So if the MPC is larger, or the response of investment to income is larger, you're going to get bigger flatter. These two parameters don't vary all that much over the business cycle. This one does. So this is the one I'm mostly interested in, was the first case. But just for completeness, we should do this one too. But mostly the variation of the business cycle is this one. This has changed a little bit, but changed in ways that were strange. Okay. After this, we're going to go back to easier stuff. This is the graphical part of this. Remember the expenditure function was E equals C of y minus t plus I of I of y plus G. It's that thing on the 45-degree line. Oops, we're using Z, I'm so sorry. That's Z equals C plus I. Remember that thing? That's ours. Then we put the 45-degree line on here. You get the equilibrium. Been doing that since 202. The slope of this thing is just how much Z responds to, here's Y, and here's Z. So if I increase Y by 1, the slope is how much that goes up. It goes up by the amount consumption goes up, which is C of Y minus T, and the amount that investment goes up, which is I of Y. So if those things, if you get more consumption so we change income this amount, if consumption responds more, consumption is more responsive, what's that do to the slope of this thing? Steeper. We start at this point, now we go through there. If I of Y is bigger, if for a given change in income, we get a bigger increase in investment, we get a bigger increase in Z, this thing will be steeper. And so if C of Y minus T or I of Y goes up, the Z curve is steeper. The expenditure function is steeper. Because for a given increase in income, we get a bigger change in expenditures. Because they're more responsive. So the mathematically inclined, it's just dz dy. dz dy is C of Y minus T plus I of Y. So this is a bigger C of Y minus T or I of Y. So it's steeper than I will in this thing. So now we can derive the IS curve. For two different cases. A flat Z, this is smaller, C of Y minus T or I of Y. Or we can do a steeper one. This is Z or larger. The interest rate is I0 in both cases. So we're starting at I0 and Y0. So what we do is just what we do always. We lower the interest rate to I1, and these curves shift up. They shift up by I of I. We're assuming that's the same for both curves. The only difference is one of these two parameters. One of those is bigger. I of I is the same, so they shift identically. So with a flat IS curve, or flat Z, you get that, Z prime. That's for I1. With the steeper one, it's supposed to be parallel on this. So we shift this up by exactly the same amount. We just take these two lines, we lift them, and we set them back down again. We follow the flat line, you'll get y1. That's c of y minus t, or I of y smaller. Or we get out here to this equilibrium. So it crosses the 45-degree line. There's the y1 with c of y minus t, or I of y larger. Oops, I cut my IS base. Oh, well. So if we just drop these down, there's one IS curve I missed. And another one. So here's one Y1, here's the other Y1. Or we get out to this point right here. We get this IS. So as this curve gets steeper, you move, the point moves that way. So you start with shift the white line up, and then just start pivoting around this point, make it steeper and steeper. This point moves in that direction. It's flatter and flatter. And so the steeper this curve is, the bigger these things are. The flatter the IS curve. So this one, we just shifted the 45 degrees line up by different amounts. This one, these two cases with different slopes. That is that. This is the most useless chart ever. Let somebody else have fun. So which one do you want me to do again? Go back over, you got it. This stuff here is probably budgeted practice. Let me just try to show you something. These parameters making sense. Let me do a linear case real quick. So we might have C equals 200 plus 1/2 y minus t. That's going to be c of y minus t. That's the responsive consumption to disposable income. So c of y minus t is the response of consumption to a change in y minus t. That's what we got. So that's what this 1/2 here is. It's just how much consumption responds to this. Then we might have I equals 700 plus 1/4 y minus 6i. This is the C of, this is what we need to I of y. Y goes up by 1, I goes up by 1/4. So this is the I of y parameter. Then the expenditure function is C plus I plus G, but they're calling Z. So it's 200 plus 1/2 y minus t plus 700 plus 1/4 y minus 6i. Oh, and this is I of I, right here. The 6 is how much investment goes up if the interest rate goes up. So 1/4 is I of y, 6 equals I of I, and 1/2 is C of y minus t. It's how much they respond when you, this goes up by 1, it's how much that responds. This is actually minus 6, I'm sorry. So Z is what? Z equals 900 minus 1/2 t, right? I should have just made t 100 or something like that. It's exogenous. Plus 1/2 plus 1/4 y minus 6i. So let me write it differently. Z is 900 minus 1/2 t minus 6i plus 1/2 plus 1/4 y. So that's our Z function that we've been talking about with the 45-degree line. This is the intercept, right? Yes.
What happened to G?
I forgot. Oh, I totally forgot it. Because I wasn't paying attention. Thank you. So, C plus I plus G. And I probably should have given G a number 2. So there should be a plus G here, and then plus G in there. Sorry about that. Thank you. So all I wanted to show you is we were saying that the size of the upward shift depends upon I of I. When I goes down, it's negative. The amount it shifts up is going to depend upon this number, because that's in the intercept. So if this were 10, instead, if I lower this by 1, this will shift up by 6. If I of I were bigger in absolute value, if this were minus 10, it's going to shift up even further. So that's the first exercise. The size of that horizontal shift depends upon the magnitude of this thing. The slope depends upon C of y minus t and I of y. When these get bigger, closer to 1, instead of being 3/4, they're 0.8, 0.9, this is going to get steeper and steeper. Help at all? So that's nodding, 1 or 2, no lie. Why don't you get too confused to ask questions? That's a nice one. Now we get to do it all one more time, except for the LM curve. In a lot of ways, this is easier. So, I think this will be a little better. The LM curve is M equals P Y L of I. It's money supply equals money demand. It's going to work a little easier for us. We'll save ourselves at least one graph. If I write this as M over P equals Y L. This is real money supply equals real money demand. These are in nominal dollar terms. These are adjusted for prices. So this is the purchasing power of money, M over P. Prices go up, the same amount of money buys you less, so it's the real value of your money. So we can graph this just like before. There's M over P is on this axis, I is on this one. So we have M over P here, and Y0 L of I here. And that's going to give us I. These are fixed too. So we give the model Y, M, and P, and it tells us Y. We're going to fix M and P and give it a bunch of different Y's and see how I varies, and that's the LM curve. So what I want to do is come over here and keep track of how Y and I are related. So right now, we're at I0 and Y0. They line up horizontally this time because the I is lining up instead of the Y. Then we want to let output go up to Y1. What happens over here to money demand? You have buying more stuff in real terms. You need more money, so money demand goes up. So when Y goes up to Y1, this shifts out to Y1 L of I. Interest rate rises to I1. So we get an LM curve where L equals M essentially. L equals M. It's all the equilibria in the money market that looks like. So that's the LM curve. That's the set of Y and I that are in equilibrium in the money market. derivation, that's the, intuitively it's pretty simple. When y goes up, money demand goes up, and that drives up the price of money. Yeah, that's it. You can see it in the equation. This number's fixed. This is fixed. These have to be equal. If y goes up, this side's bigger. So how do we make it smaller? By letting I go up. So when y goes up, I has to go up to make this go down, so this product is still equal to this. So it's that simple. This makes money demand go back down. So all you have to look at is if m over p goes up, the curve shifts up. That's what I want to show you next. That's the result graph. Totally unique. Let's see if we can do it without math. Or without derivatives anyway. So let's remember that we have m over p equals y L of I. So we have this LM curve sitting here. LM depends upon m0 over p0. And we're at I0 and y0. Let's just try to intuit, figure it out without graphs or doing the calculus part, how this curve shifts. I haven't done the calculus for shifts. Let's just see if we can figure it out. So suppose that m goes up or p goes down, so that m over p goes up. That's going to make this bigger than this, right? Let's hold the interest rate constant. So keep this constant. What has to happen to y to make them equal again? It's got to be bigger, right? So at the same I, y would have to be bigger. So it must be that the LM curve shifted out. So just look at this. Say, okay, hold that constant. If this goes up, that has to go up. So at the same I, you'd have a bigger y. You could do that mathematically if you wanted to. You would find dy dm or dy dp given d all else equals 0. So you totally differentiate this, and you find dm, dy, everything else held constant. I won't do it. That's how you. Let's do it graphically. Take that side by side thing. So here is, say, m0 over p0. Here is y0 L of I. Here's an LM curve for m0 over p0. And we're here at I0 and y0. I'm gonna look at in this direction this time. We'll do it a little bit different, but it comes out the same. You can do either one. I could have asked, hold y constant, what's I have to do? If this goes up with y constant, I has to fall. That's what you can also do it in that direction. Hold y constant. You could also find di dm, all else equal. So that's what we're going to do. Let this go up to m1 over p1, and that's bigger, like over there. Income hasn't changed, but now we have an I1. So at the same level of income, interest rate's lower. That's an equilibrium, so it has to be on the LM curve. So it must be that the LM curve shifting out or down, however you want to say it. So when M over P goes up, the LM curve shifts out. So we want to be monetary policy, we'll say, okay, suppose M goes up, that shifts the LM curve out. So later, don't bother to write this, but later we'll say, okay, what does monetary policy do? Well, if we increase the money supply, we get a higher level of income and a lower interest rate. So we'll be able to look at policy. Then we can ask, when is monetary policy more or less effective, depending on the slope of the IS. We can also drive an aggregate demand curve from that. I'll see. So if M over P goes up, LM shifts out. I suppose I should pretend I can look at my notes. Huh? One more technical thing, and then we can stop. So I think it's break time, and I think you need it. What's happening coming out? What's that? Okay. Hopefully the video will work. We shall see. I was writing. I don't know. Sorry. I just can't make them for this kind of stuff. It's just too hard. I'm tired. I don't get to San Diego till 12. We all get San Diego. Oh, the class video has been retweeted about 10 times. That just makes me laugh. The videos that I put up have had 780,000 views. Really. The one that's really, probably 600,000 of those are 421.
Do you get paid for that?
I put ads on and I give the money to the department. I don't make that much, it's like $100 or something. I could make a lot of money off my blog, but I could. No ads. I'm so happy that finally posted. Tuesday's video is 53% complete. Then I have to upload it. Maybe a little. Good old remote test out. I know some of you said you had to leave. Before you forget, because I'm going to be gone the rest of the week and because you have a homework due next week, I'm going to have office hours on Monday. I'll be there at 1:30, normally into 2:30. I'm just going to stay there until 5 o'clock. So I'll be there pretty much all afternoon on Monday to sort of make up for being gone. And you're welcome to come by and you know, I won't want to just answer your questions for you, so I hope you have questions for me. Don't just come in having done nothing, trying to get me to do your homework, because I'm not going to do that. But I'm more than happy to give you all the help you need.
Can you talk about the midterm a little bit? Like what, that's next Thursday, right?
Yeah, I'll do that on Tuesday. I'm not ready
Okay.
yet. But it'll be essay, not multiple choice. I hate multiple choice.
Okay.
And I never ever go into, okay, I need this cue, sorry, because I do this sometimes well. So let's start. So the midterm, yeah. So I am not the type that goes into the book and pulls things out of footnotes or other sorts of things, because it just makes people mad, and I don't need to do that. The things I thought were important were the things I talked about in class. And so it's going to be, quite frankly, since they're here, and that probably won't get processed in time, quite frankly, it'll be over the material I covered in class. I could say, show the IS curve is steeper when, show the IS curve shifts out if,
Okay.
what happens to the IS curve if government spending goes up, all kinds of derivations. Anything I did on the board except the math part, as far as I'm concerned, is fair game for the exam. If you know your notes inside out, everything that's in them, you're going to be fine if you understand it. If you don't, you're not going to be fine. So it's really going to come down to exactly that. So I never try. I've been doing this long enough. You don't have to fool people. You don't have. I'll get this. If I try to fool you, I'll get the same distribution with a lower mean. So I may as well make you happy and ask straightforward questions. But it doesn't mean that it'll be. It could be like homework problems with numbers that are easy, so you don't need calculators. There's a hint. Someone else have a question?
So it's more conceptual than.
Yeah, probably so.
Okay.
I'm mostly, the math stuff is just to help you build your intuition. But I'm really interested in that you understand the models and how to manipulate it. So what I'm after is that you can ask models questions. What if people are less responsive to interest rates in recessions? How does that affect fiscal policy? Those sorts of things. The other thing I'll say is what we've just done is probably, it is the hardest thing we'll have on this midterm, and it's one of the harder things we'll do all year. We'll do one other thing where we use the ISLM curve with different slopes. And then we have to do things like figure out, this is the one where the MPC is up. And we'll want to know, well, when is it more or less effective? And then you'll have to shift these things out, and you'll have to know how to shift them and things. That'll be a little bit hard, but it won't be quite like what we did. So this is kind of the hardest part, I think, of what we did, because we're building up the things we need to answer the questions I want to get at. So we got to build the technical apparatus before we can do the fun stuff. So, but yeah, I'm more interested in those kinds of questions.
I have a real quick question on the IS curve. So that number, that's 6, it's the 6I. Is that 6 a responsiveness?
Yes.
Interest rate?
The responsible investment to the interest rate.
Okay.
So yeah.
So as that number goes up, there's going to be a greater shift. Is that
Right, exactly. I can't remember what I did. Something like that.
Yeah.
I don't know what it was. Yeah. So that's because the interest rate goes down. This is a negative change. Negative and negative is a positive. It shifts up.
okay? Got it.
And it shifts up more when the absolute magnitude goes up.
Got it. Okay.
Yeah, so that -6 is the I of I. And this thing is what we would call an I of Y. It's DI, DI.
Got it.
D big I, D little I. This one is DI, DY, I of Y. All else equal, so it's a partial. So now we have to do the slope of the LM curve. That part seemed easier than it did for the IS curve. So I think I'm going to do the result first and then try to explain it. Let me show you. What I want to do this time is see what happens to the LM curve if I have a steep y0, I0 versus a flat And I just want to say, okay, suppose it's flatter or steeper, what happens to the LM curve? And then I'll say, why might this be flatter? I don't want to confuse the, I think the IS curve, we got all worked up in why these have the slopes they have, but let's worry about that later. Just find the result, and then we'll ask, when would this be flatter or steeper? So this is the money demand curve. So we're going to start off with this for I0 and Y0. And we're going to increase the interest rate to I1. Excuse me, that's not what we're going to do. We're going to increase income to Y1. Both of these curves will shift out by the same amount. Remember, when Y goes up, the money demand curve shifts out. This intersection point will just shift out. So with a flat curve, there's Y1L, and the curve is flat. We'll go to this interest rate here. There's I1 with a flat curve. So in that case, we get that LM curve. With a steeper curve, the interest rate goes all the way up to there. See that? So there's the intersection with the steeper curve. So as this thing gets steeper, the interest rate moves up. So just shift this flat one out and then start making it steeper, pivot it around that point, and the interest rate gets bigger and bigger. So in that case, we get to this I1 here, same shift in Y, but a bigger shift in interest rate. So now we're going to get a much steeper LM curve. So what we've shown is that a steeper money demand curve gives us a steeper LM. So that's just a technical. I didn't say when will this be flat or steep. But just suppose we had a flatter or steeper money demand curve. That'll give us a flatter or a steeper LM curve. That's all there is to it. So now let's ask, when is the money demand curve flatter, steeper? Last time I started here, and then you got all lost, and then this part got muddled. Technically, it's not hard. You just start with two different slopes and drive the LM curve twice. So here's the money demand curve, right? I'm using real money demand. So this is Y. So there's the rise and there's the run. Here's the interest rate. Here's money demand. So the slope is what? It's the responsiveness of what? This is the change in money demand, right? And this is the change in interest rate. If this went up more for the same fall in the interest rate, we have a flatter curve. So the more that money demand responds to the interest rate, the flatter the curve. So it's the responsiveness of money demand to the interest rate. That turns out to be L of I. See that? Because real money demand is YL of I. The slope is just, it's very simple. You lower the interest rate and money demand goes up. It goes up by the amount this function goes up. And that's L of I. So when I goes down, this goes up by the responsiveness by L of I. And so the bigger L of I is, in absolute value, it's a negative number. But the bigger L of I is, in absolute value, the flatter the LM curve. So the slope of the LM curve depends upon the responsiveness of money demand to the interest rate. So this is the same as saying steeper M, that's the same as saying a smaller responsiveness of money demand to the interest. Why do we even care about this? Why am I torturing you? This stuff. In the real world, we think the LM curve is something like this. And the reason why its slope changes over the business cycle, I meant for this to be completely flat at some point. This flat part is called a liquidity trap, if you've heard that term in the news or anywhere lately. And that liquidity trap happens when L of I is infinite. We believe, for reasons I'll talk about later, that as income falls, this L of I parameter changes in a way that makes this really flat. Now notice that if we do fiscal policy up here, if I increase government spending so the IS curve shifts out, I don't get much of an impact on output at all. So near full employment, fiscal policy might not be very effective. But in a liquidity trap, the same exact change in the IS curve gives you a much larger change in output. So we think this is a way of showing that as L of I gets smaller and smaller, fiscal policy gets less and less effective. It's because you have complete cracking out. You've heard that. So that's why I'm doing this. Saying, okay, when is it steep, when is it flat? Because it has a huge impact on the effectiveness of fiscal policy. And if you're stuck in a liquidity trap, this model tells us that fiscal policy would work. What monetary policy is, if you're in a situation, remember we said M shifts this curve out? What it does is it shifts it like that. So if you do monetary policy in a liquidity trap, what happens? Nothing. But over here, near closer to full employment, you're getting changes in output when you shift this thing out. So it restores it. So it has more effectiveness in full employment than it does in recession. And you can also have to worry about the slope of the IS curve, because depending on how the IS curve is sloped, we get different impacts too. And so the policy effectiveness of monetary and fiscal policy is going to depend critically on the slopes of these curves. When you're stuck in a liquidity trap, it may be that fiscal policy is your only way out. Maybe not. We'll look at those questions. But anyway, it's not just, gee, here's the way I can push the model just to make the class hard. I want to try to get at some questions that are really important in terms of understanding monetary and fiscal policy. And we can't do that unless we know about the slopes of the IS. So what do you need to know? 3 things. Derive these curves graphically. Understand when they're flatter or steeper graphically and intuitively. And understand when they shift. let's just check our intuition. Check our graphs. M over P is Y L I, right? Let me find the slope of the LM curve mathematically and see if it's true that if L of I goes down, it gets steeper, because that's what I'm claiming. Let's check that. So here's the total derivative. For the slope, I need to hold M and P constant. I just want to know how are Y and I related all else equal. So this is 0, this is 0. So 0 equals dy L of I plus y L I di. So di dy, the slope of the LM curve, is minus L of I over y L of I. So as this thing goes to 0, what happens to the slope? Steeper and steeper and steeper. That's what we claimed. L of I goes to infinity, the slope goes with the flow. So the flat part is when L of I is near infinity. That's a liquidity. That happens when money and bonds are perfect substitutes. But again, that's something I'll take up later. Okay, the house is built. Now let's play it. Now what we do is put the IS curve, which shifts with G, T, and autonomous expenditures. Those are the shifters that we looked at. So we showed last time if any of these things change, the IS curve shifts. We know about its slope. We know how to derive this. We have an LM curve, and it depends upon M over P. Where those things intersect, we have an equilibrium. So that's the one pair, I and Y, that's an equilibrium in both the goods and the money market. So there's only one unique equilibrium, it's linear. There's one unique equilibrium, there's one unique pair, I and Y, that can solve both markets simultaneously, and that's this one. Now, I haven't really talked about the forces that drive us to this point. It's kind of technical to do that. I don't know if I will or not. But you can also show that there are forces out there that will drive you to that point if you're not on it. You just, it's in my notes. I'm supposed to talk about it. I think I'll move that page to another place. So let's talk about policy. So let's look at fiscal policy. In the short run, because we're still holding price constant in this model, we're not letting the price vary yet. Our results will be different when we let prices change. So what we're going to do is valid for a time period when prices are held fixed. So fiscal policy is a plan for government spending and taxes to achieve some goal, whatever that goal might be. And so let's look at either a T up or T down. That way I'm sort of not, Democrat or Republican. I don't want to take a position in politics. So either one will stimulate the economy in this model. Take your favorite government spending going up or taxes going down. What does that do to the IS curve? What did we show happens to the IS curve? We said anything that increases spending, it's not I, shifts it out. So you get IS or G up or T down. Everything else, that's held constant. So the model tells us that output would go up and the interest rate would also go up. So this model says when one of those things happen, you get an increase in income and a increase in the interest rate. Classes before this one. So 3 hours of talking and this starts to go. What's the intuition? Let me just help you out. I'm going to break it down this way. Let's first move out to here. That's not the new equilibrium point. But government spending goes up, shifts out the IS curve by that amount. The increase in income causes Y L of I to go up. Causes money demand to go up. So that money demand is greater than money supply, M over T. What does that do? What's the price of money? Interest rate. So it drives interest rate up. But that causes investment to go down and income to go down. So this is the first change here. This part from here on is all to move us back to this point. So you see here, from this income level here, the interest rate goes up and output. This fall in output here is an offset to this one. This is never going to be bigger than this one. There should be an up here. So I'm just decomposing it in a way that's intuitively easy for the questions you want to ask. You can think of this first shifting out and the interest rate constant. That throws the money market out of equilibrium. So interest rates rise and incomes fall to bring the money market back into equilibrium. So we're all done, we end up at this point. So this is an offset. This is called crowding out. What's going on here is you have Y equals C plus I plus G. If it's government spending, G goes up. Let me do it that way. If it's taxes, C goes up. Let's do this one. Government spending goes up, so that causes output to go up by the multiplier. So right here, there's actually the simple multiplier tells you how much that goes up. It's a horizontal shift in the IS curve. But then the increase in income causes the money demand and interest rates to go up and investment to go down. So this falls. So the net impact is the primary shift plus the crowding out. Government spending crowds out private investment to some degree. And when this LM curve is really steep, what would happen? If the LM curve looked like that, what would the change in output be? Be zero. There'd be complete crowding out. That's what we're going to get in the long run, by the way. And when it's really flat, you get very little crowding out. So depending on the value of L of I, we just talked about, you'll get different. I'll do the policy effectiveness later. I'm just interested in this right now. This other stuff is just setting up what we're going to do next week. But you can see that depending on the value of Li, the slope of the LM curve, you're going to get different amounts of crowding out. In the liquidity trap, it's completely flat. So you get no crowding out of private investment. Near full employment, you can get complete crowding out if this thing is really steep. So that all government spending does is reduce investment in the private sector dollar for dollar. In a liquidity trap, you don't tend to see this at all. The reason is that in a liquidity trap, remember that I of I parameter? Anyway, we'll come back. Yes, sir.
What does crowding out mean?
So crowding out means that government spending crowds out private investment, makes private investment shrink. When government spending goes up, we haven't increased taxes. So there's more borrowing. There's more demand for money from all. That drives interest rates up. That makes private investment more expensive. So private investment tends to fall. So the government is crowding out private investment by competing for the same funds that everyone's borrowing. So when government spending, when they deficit spend more, they have to borrow more. That drives interest rates up, it drives investment down. In a severe recession like we're in now, where there's lots and lots of excess reserve that no one can lend, there's extra money in the financial markets. So when the government borrows more, it doesn't have much of an impact on interest rates because of all those excess funds floating around. So you don't tend to see crowding out. So in a recession, this effect tends to be fairly small. Near full employment is nearly 1-to-1. And so where you are in the business cycle makes a big difference about how much crowding out you're going to see. The main reason for it is going to be this. I'll do that later. I'm sorry. The math for this one's kind of hard. I don't know if I should do it. So that's fiscal policy. What about monetary? AUT is autonomous expenditures. They're just too lazy this slate to write it all out. Auto. recruitment block. This is the model he's been saying it's really done well during the crisis, this ISLM. Okay, simple. We just did this. You increase M, what happens to the LM curve? It shifts down or to the right. LM, M1, M2. What if the IS curve were vertical? Bad news, right? It's flat. Good news, in terms of the effectiveness of policy. It also depends upon the slope of the LM. That's much harder, so I'm not going to do it. So what's the intuition for monetary policy? The result's easy. M goes up, Y goes up, interest rates tend to fall. They actually do the policy the other way around. They say, let's lower the interest rate, and that requires them to increase the money supply. The model works essentially the same. So, yeah. So when M goes up, M over P goes up because P is fixed. So money supply is greater than money demand. So what happens to the interest rate? Down.
It goes like surplus,
Hmm.
it goes like, the money goes like surplus, goes like that.
Yes, and so you take the money and you buy bonds. That drives the price of bonds up and interest rates down. So investment goes up, income goes up. Then there's an offsetting effect. I'm going to leave that out for a moment. That's basically what goes on right there. I mean, there's words that go with this. This is just shorthand. I mean, that's not the intuition. The money supply goes up, that means real money goes up, so real money supply is greater than real money demand. So people take the extra money, they buy bonds, the price of bonds goes up, the interest rate goes down. Because loans are cheaper, people invest more. When they invest more, that's an increase in demand. So the inventories start to fall. When inventories fall, that drives output up. And then I could feed this back into the money demand. That causes money demand. Anyway, that's enough. That's the basic intuition. We just said if the IS curve were vertical, instead of this way, what would the change be? 0? Just for fun, don't worry about this for now, I'll come back to this. But where would that fit in here? If that's because of I of I, that's this right here, right? That's I of I. Suppose I of I were 0, what would that happen to output? It wouldn't change at all. Because when the interest rate falls, there's no change in investment, so no change in income. So when I of I is 0, monetary policy is ineffective because you can't get investment to go. Monetary policy works by lowering interest rate to stimulate investment. If you're in a recession, it's Keynes said there's many a slip, the next cup and lip. So when you're in a recession, you lower the interest rate, you don't get any response of investment, so it's ineffective. So that's one of the reasons monetary policy tends to be ineffective in a recession, is this link is really hard to make happen. You can change, and then you hit the 0 bound, and you can't move this hardly at all. Even before you hit the 0 bound, it's not all that effective, and once you hit the 0 bound, you can't move this hardly at all, so you can't get output to go up. But fiscal policy might be effective in that case.
So interest rates are so low that people aren't investing at that low rate anyway, so.
It's because the economy is in such a dour shape that even at very low interest rates, they're still unwilling.
Yeah. But monetary policy looks like it's positive on both ends, interest rate going down. And
The interest rate does go down, even in this case.
no, but I mean, when the IS curve isn't completely vertical, which is
Yeah, yes.
isn't it the best case scenario for interest rates to go down and output to go up?
Yeah.
So would monetary policy be over fiscal policy?
when it's effective.
Okay.
And that's why all during what we call the Great Moderation, when we had from 84 to 2007, the economics literature hardly talked about fiscal policy at all. It's in the hands of Congress, it's really hard to do, you can't depend upon it, it's not systematic, there's a lot of ideological things attached to it, blah, 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 blah. And so even though fiscal policy probably works in normal times also, it's much more politically charged and much harder to use. We've got this independent body called the Federal Reserve that doesn't have all these political constraints.
Right.
So during normal times, we tend to rely upon monetary policy and just shift fiscal policy in the background and don't worry about it. Plus, in good times, fiscal policy tends to just crowd things out anyway. And so it's not very effective. When you get into a recession, though, things start to change. Monetary policy loses its effectiveness both because you get, it's not literally zero, but it's close to zero. You don't get much impact, and there comes a point when you hit the zero bound when it's really hard to manipulate this. You can still do QE and try to bring down long-term rates. They were talking like, 0.1, 0.2 changes in long-term interest rates through QE. Very, very tiny things get much impact on investment. So monetary policy becomes much more difficult for those reasons during it. And you can see all the debates right here in these intuitions and these diagrams about exactly all the things that have been debated out there during the process. And that's exactly what. So that's what I'm trying to get at, is when is monetary policy more or less effective? Right now, I don't really want to ask those questions. I'm just trying to do a simple, what's the intuition for this? And this is just setting things up for what we're going to do later. So all that torturing with the last 2 days hopefully has some payoff in terms of understanding things. You can ask all sorts of things. Suppose the Fed has a constant interest rate rate. What's that do to the effectiveness of fiscal policy? Suppose you do fiscal policy, so you have IS, G0, T0, LM, M0 over P, and you have an interest rate. And we cut taxes. Last time I've been doing government spending, let me cut taxes and stuff. Let me be ready. Nothing actually happened. And so we cut taxes. IS, G0, T1. So before the Fed responds, output would go up that much, interest rate would go up. But if the Fed's followed a constant interest rate rule, what should they do? They need to increase the money supply. They need to hit that point, right? So now the Fed would increase the money supply. So first this would happen. The Fed would say, oh no, interest rates are higher, we've missed our target. So what do they need to do to hit their target? They need to increase the money supply. That's going to cause output to go up even more. And so that kind of a policy would actually reinforce. The lesson I'm trying to get out here is actually a somewhat simple one. It's that we can't really understand fiscal or monetary policy unless we know how one responds to the other, particularly fiscal policy. So if you want to know how fiscal policy works, you have to know how the Fed responds to the policy. The Fed could have also said, oh wait, we think this is full employment. This is going to cause inflation, so what should the Fed do in that case? They could bring the LM curve back to try to prevent the inflation. They could say, oh, we're opening up an inflationary gap here. We're holding prices constant, so this is hard to see. But if you were worried that an increase in output would overstimulate the economy, and you think fiscal policy is doing too much, This is Richard Fisher of Dallas likes to make this argument. Then what the Fed should do is offset fiscal policy by lowering the money supply in response to fiscal policy. That's what Greenspan threatened to do when he was Fed president. He said, you know, you guys are going to try to stimulate the economy with fiscal policy. If you do, the Fed will think that your economy is overstimulated, and we're going to raise interest rates to offset it. So go ahead if you want to and cut taxes and increase government spending. That's your choice. But be aware that the Fed's going to offset it by simply raising interest rates. And so you really can't think of monetary and fiscal policy in isolation. You have to think of them as a whole. Well, I got places to go. You're tired of being here. We only have 2 minutes left. I can't start something new.